So today, we're going to jump into something that honestly kind of breaks your brain a little bit. It's a paradox right at the heart of economics, where a perfect logical math rule seems to completely fall apart in the real world.
All right, let's just get right to it. Think about this for a second. When can a perfect, totally logical math rule just be impossible in the real world? And no, this isn't a trick question. It's actually the key to this whole puzzle we're about to solve.
So we're kicking things off with what I call the cost function paradox. And this is where you see this head-on collision between the clean, predictable world of math and the messy, often chaotic reality of, actually trying to run a business.
Okay, so first things first, let's do a super quick refresher on what a function actually is in math. It's a really strict rule. For every one input, you get one and only one unique output. Think of it like a vending machine. You press button C4, you expect that specific bag of chips, right? You can't press C4 and sometimes get chips and other times get a soda. No way. That would just break the whole system. One input, one unique output. Simple as that.
Now, in economics, one of the most basic ideas is that your total cost, which we call C, is a function of the quantity of stuff you produce, which we call Q. The formula is C equals F of Q. So, going by the rule we just talked about, this has to mean that for any given quantity, let's say 100 widgets, there should be one and only one possible cost to make them. Make sense, right?
Well, here's where reality comes crashing through the door. Just look at this. A company wants to produce 100 units. On Monday, they try one combination of inputs, and it costs them 120,000 naira. Then on Tuesday, they try a slightly different method, and the cost drops to 110,000. By Wednesday, they finally perfected it, and it's down to 100,000. Wait a minute. That's the same output, 100 units, but with 3 completely different costs.
And boom, that is the paradox in a nutshell. The math rule demands one input, one unique output. But business reality shows us that for one input, making 100 units, you can have many possible outputs or costs, depending on things like efficiency or waste. So what gives? Does this mean that this fundamental economic formula is just wrong, fundamentally broken?
And that, my friends, brings us to the solution. It's what I like to think of as the economist's secret weapon for fixing this mess. It all boils down to something called the efficiency assumption. And honestly, it's a pretty brilliant move.
And here's the secret sauce. It's actually genius. Economists don't try to make the messy reality fit the perfect math. Instead, they just cleverly redefine the problem itself. They add a new condition to the rule.
Yeah, this quote right here just nails it. The cost function isn't meant to capture every possible cost you could ever have. Nope. It's designed to trace the lower envelope, which is just a fancy way of saying it only cares about the absolute best-case scenario, the cheapest possible way.
So here's the big reveal. The economic cost function doesn't just mean the cost. It means the minimum attainable cost to produce something, and here's the kicker, assuming the company is being perfectly efficient. So what about all those other higher costs we saw, the 120,000 and the 110,000? Poof! Economists basically just ignore them. For the sake of the model, they don't count.
This whole idea can feel a little abstract, I get it, but it gets so much clearer when we can actually see what's going on. So let's visualize this whole solution, because this is where it really all starts to click. Okay, imagine you're plotting every possible real-world cost for every level of output on a graph. You wouldn't get some nice, clean line. Oh no, you'd get this messy cloud of dots all over the place. We can call it the cloud of inefficiency. Every dot that's higher up represents some kind of waste, a mistake, or just a less than perfect day at the factory.
But here's the trick. Economists look at that messy cloud and they just ignore most of it. They're only interested in the lowest possible dot for each level of output. And when you connect all those lowest dots, you get this single clean curve right at the bottom. That perfect line is the frontier of efficiency. And that is what they define as the true cost function. So how do they actually find that one specific point, that one single cheapest cost mathematically? Well, it's kind of like a 3-step recipe. First, you set your target, how many units you want to make. That's your isoquant curve. Second, you map out all the different ways you could spend your money on things like labor and materials. That's your isocost line. And third, you just find the one single spot where your budget line just barely kisses your target curve. That one point of contact, that's it. That's your minimum cost.
Now, I know what you might be thinking. This sounds like a clever little academic trick, right? Just a way to make the math work out neatly. But this assumption of perfect efficiency is actually an incredibly powerful and super practical tool, both for economists and for businesses.
So, why does this all matter at the end of the day? Well, for starters, it creates a benchmark. It's like the gold standard for efficiency. A real business can look at its actual costs, compare them to this theoretical minimum, and see exactly how much fat there is to trim. Plus, this is the only way we can calculate things like marginal and average cost. And trust me, those are absolutely essential for making huge decisions like how to price your products. Really, this one simple assumption is the bedrock for tons of complex economic models we rely on every single day.
And all of this leaves us with one last, really big question to chew on. We've just seen that a core tool in economics is built on this idea of a perfect, idealized world that doesn't really exist. So if the models are perfect, and our world is, well, not, how should we actually use them to navigate our messy, imperfect reality? It's a great reminder that theories are powerful, for sure, but they're guides, not perfect pictures of the world.